We are doing the displacement analysis. So any question before we start? So what we are going to do on displacement analysis, we are given a mechanism like a 4-bar mechanism. The 4-bar mechanism is running. Something like this, it's a crank arc mechanism. We would like to find the position of all points and orientation of all links at any specific time of the motion. So if I label this by A, B, C, and D, this is link 2. I labeled the angle of link 2 with the ground in counterclockwise by theta 2. For link 3, I measure the orientation or angle of link 3 with the ground at this point. You can measure at this point as well, theta 3 and theta 4. For any displacement analysis, you need to have these terms. Constants, A, B, C, and D are constants because the length of the links are not varying. Variables, we have 4 links, 3 of them moving. Link 2, 3, 4. All 3 links which they are moving down, they have pin. So meaning that all variables would be the angles. So theta 2, theta 3, and theta 4 representing them. Nouns, it's always constant. You look at the degree of freedom for the mechanism, M or DOF, and find the degree of freedom. In this case, it's going to be 1 degree of freedom. So then you look at the variables. Depending on the degree of freedom, you should know the same number of degree of freedom from the variables. So since the degree of freedom is 1, one of the variables should be given. In this case, I assume theta 2 is now. Then I'm going to solve for the remaining variables. So as you see, the number of variables which should be now should be equal to the number of degree of freedom. So if the mechanism has 2 degree of freedom, if one mechanism has 2 degree of freedom, then you should pick 2 variables as noun and solve for the remaining variables. So the unknowns would be the remaining of the variables, which is theta 3 and theta 4. So now I'm gonna do displacement analysis based on the constant variable noun and unknowns for a 4-bar mechanism with a graphical approach. I will start with graphical, then we move to so you pick 1 point on plane and label that as 4A, which is representing the location of this joint, joint 1. Then D is given this noun along the ground line, pick the D. I labeled that as a OB. So you know the D, because D is noun, just find the location of OB. Then you know the length of link 2, which is A, and also you know the angle. Suppose the angle is theta 2, which is given, plus A. Right here, draw a link with the angle of theta 2 from the graph, and find the location of joint A. This is joint A. So if I find the location of joint B, I find the location of joint B, I can connect OB to B and A to B, and we are done with the graphical approach. After that, we can measure the angle of theta 4 and measure the angle of theta 2. So what you can do, we know that link 3, it has the length of B. So draw a circle with this center of A, and the radius of B. So any point in this circle, has the distance of B from the point A. So any point on this circle can be candidate for the location of joint B. But we don't know where it's gonna be, that point. So another information that I have, I know that point B has a distance of C from this point. So just draw another circle with the radius of C and the center of OB. So any point in this circle is gonna have the distance of C from the center, so it can be candidate for the location of B. So this point has both a specification. This point is located on this circle, so it has the distance of B from point A. This point is located on this circle, it has distance of C from OB. So I connect this to this and connect this one to this point, and I can locate point B. But what I'm looking for is angle of theta 3 and theta 4. You should measure by drafting instrument, measure this angle and report this as theta 4. And measure this angle and report this at theta 3. So with graphical approach, you can just say theta 3 equals to whatever is the number coming from the measurement, and same thing for theta 4. So this is what you need to do for 4-bar mechanism displacement analysis with graphical approach. Good? We are going to do a class activity. Is there any? Yes.
But still don't like I don't get it. So
The circle.
like how do you draw the circle? Does it depend on
It depends on, we know the length of link AB. You know the size of that. It's given. Constant.
Okay.
So I draw a circle with this center. If you want to draw a circle, you just need a center and radius. Then you can draw a circle. This is the center because point B has a distance of B from the center. Then draw a circle with that radius.
Then put B.
B, yes. And do the same thing with the center of OB and the distance or the radius of C.
Okay.
So you get the second circle. So I'm looking for a point which has both a specification. It should have the same this distance of B from point A as well as distance of C from point OB. So this is the point that I have. Yes.
So point B has to be where
Point which has to be?
the two circles meet?
Yes.
Okay.
Because this is the point which has the distance of B from A, as well as at the same time it has the distance of C from D.
How about the other point, like the cross version of the...
It's gonna be the class activity.
Oh.
I'm asking you to do. So I draw the circle, two circles. What are the possibilities for the intersections of two circles? Think about that. All possibilities, just think about all possibility of the intersection. Then I will call number.
So the last problem was like, it was kind of similar to this, but it was like a slider, like where point B is, like moving left and right. And it was given a dimension offset. The dimension was called offset.
We are gonna cover that. Sure.
Did not know.
Yeah, if you remember, I said some of the problems after one class we couldn't cover that.
Yes.
So today. All right, number 5. Abdul Rahman. Is not? Okay. Can I borrow your pen? Sure. All right, number 12. James. Where are you? He's not? All right. Number 27. Charles.
Hi, Darlene here.
Okay, what do you think?
It's unfortunate. There would be two. It would be the maximum and minimum transfer time. The maximum and minimum points. I'm thinking
How many possibilities? I mean,
two.
2. What would be those possibilities?
Would be where it toggles.
Did you, what we are looking for, I draw 2 circles, through this one and this one.
Yeah.
They have intersections. How many different possibilities you might see on the intersection of 2 circles?
Two.
What would be 2? So something like this?
Yes.
What about this?
Well, then there's only one.
And what about this?
Then there's none.
So there are 3 possibilities that you might find on the intersection of 2 circles. So for two intersection, we are gonna have two solutions. One solution up there, right here. The other solution is gonna be right here. If you connect A to this one and OB to this one, still this length has the distance of C and this one has the distance of B. Then, if I ask you to measure the angle, you should draw the line at point A. It's a ground line. You start from this point, moving in counterclockwise direction. Don't go in this direction. All the way to this line. Same thing for theta 4. Starting from this point, moving along counterclockwise direction, all the way to length 4. It's going to be theta 4. So we are going to have two solutions or two modes. Mode 1 or mode 2. Doesn't matter which one is 1 or which one is 1 or 2. We have two modes. For one intersection, we have one mode and for zero intersection there is no possible solution. These are the objects.
Just two circles?
For two, yeah. I draw this circle and this one. Okay.
What about
This one.
Yeah.
Okay. I know the length of the link and the angle. I can simply draw this thing. Can you do that? You know the theta 2. And you know the length of the link. So you can end up to point A. You can locate point A, the position of point A.
That's why we did the...
But for point B, I don't know where it's gonna be because I don't know this angle. For that reason, I'm looking for the solution. I draw a circle with this center and the radius of B. Any point in this circle can be a candidate for position of point B. So it's not going to help me. I need to draw another circle by the center of OB and the radius of C. It's going to be this circle. So the intersection of two circles, if there is any intersection, has these two specifications. It has a distance of B from A. At the same time, it has a distance of C from OB. And this is what I'm looking for. I would like to have a mechanism with B here and C here. And then I can measure theta 3 and theta 4. So this is going to be the location of my mechanism when link A is at theta 2.
So just to locate the points, A, B and...
B1, yes. One of them is going to be on the top, one of the possible nodes. The other one will be if I move from point B1 to B2, which you can see at the bottom of the But these two circles might have two intersections, one intersection, or no intersection. All right, let me solve one example. Then we move on a slider crank. Now I'm gonna use the real numbers. For a linkage for a 4-bar mechanism with this dimension, A is 2 inch, B is 7 inch, C is 9 inch, and D is 6 inch. So length of the mechanism are given. We would like to know at theta 2 equals to 30 degree, do the displacement analysis. So I gave you the length of the mechanism, and I have to provide the value of one of the variables. I provided the theta 2, and I'm looking for theta 3 and theta 4. I'm gonna repeat myself here, but just having the number. So I pick the point OA. Right here. The D is 6 inch. 1, 2, 3, 4, 5, 6. OB. This is D. D equals to 6 inch. Then I know the angle of theta 2 is 30, so it's going to be 30 degree going in counterclockwise direction. And the length of A is 2. 1, 2. I can locate point A. If I locate point B, I'm done. But I don't, how can I do that? I know that the length of link B is 7 inch. I draw a circle with this center and the radius of 7. Something like this. R equals to 7. So I know that the length of links 4, which is C, is equals to 9 inch. So I'm going to get with this center, and the radius is going to be 9 inch. So it's going to be somewhere here. One intersection is going to be up there, one intersection is going to be down there. If I connect them, I will find one node up there, OA, A, B, OB. So for this node, I can measure theta 4 and report that. For this one, I can measure theta 3 and report that. So let me show you
So for those angles, they're measured, there's no calculation?
Yeah, because we are working on graphical approach. In graphical, we don't do any.
So number 5 on the homework
Yes.
for measuring?
Mhm.
Yeah, okay.
So theta 3, we measure, it's going to be 88.83. So theta 4, if we measure, it's going to be 170.28. So second node, the measurement can have some error, that's fine. I mean, second node is going to be the other intersection, which is right here. OA, A, B, OB. Then, if you want to measure theta 3, you should move in counterclockwise direction. This is theta 3, 2. Theta 3, 2. 2 representing the mode number. So theta 3, 1, meaning angle with angle for link 3. For mode 1, theta 3, 2, meaning that angle of theta 3 for mode 2. Don't measure this. So because you are going to move in clockwise. So if this one is 115, theta 3, 2 would be 360 minus 115.21 to 44.79 244.79 this angle, and this angle theta 42 again don't go in this way, you should measure it likewise. 360 minus 143 270 or 260.34.
Question.
Yes.
So since can we use MATLAB to do this?
For graphical,
Instead of using drafting, just like draw the stuff on MATLAB.
you can, but it would be great. But in the exam, if I ask you to do by drawing, I expect you know how to do drawing too. There's no problem. I would like to see how to get the result by graphical. So if I want to report the result for theta 2 equals to 30, we have two modes, theta 3.1 and theta 4.1, theta 3.2, theta 4.2. Theta 3.1 is 88, theta 4.1 is 117, theta 3.2 is 244, and theta 4.2 is 260. Two modes, so meaning that the circles have two intersections. Any question before we move on?
What is the percentage of area you would accept for this?
For example, if it's 88, if you measure up to 94, 95, that's fine.
You mean the other way?
Yeah.
So plus minus.
If I see that you have, because I can see how did you draw that. If I see that the length of the link is correct, and you draw a circle, and you can find the intersection, it's acceptable. Even if it shouldn't be too far from. All right. Let's look at. We are doing displacement analysis for the different mechanism, which is offset slider crank. All right. This is you have seen this. It's a slider crank. When this link is running, the slider is moving back and forth along the ground. This is offset. The slider has an offset from the ground. So the offset is, the distance of the offset is C. So I'm just labeling the links. This is A, this is B. We have 4 links. 1 ground, 2, 3, and a slider 4. 4 links. 1 is ground, so 3 moving links. three of the links moving. This link, and slider. Two links, meaning link 2 and link 3, they have rotational. They have rotational motion. So because we have pin, and pin right here. Since two links have rotational, two of the variables should be, two variables are angles. Link 2 has the angle of theta 2 from the ground, representing that angle. Link 3, I can represent the orientation of link 3 from the ground at point A or point B. Here you see I measure the orientation of link B at point B. Both are correct, so depending on how you label the links and the angles, both ways will be correct. And one of the links is the slider. One link has translational motion, meaning the variable corresponding to this should be distance, which is this guy. I label with S. Here it's labeled by D, S or D. Sometimes I label by S, sometimes I label by D. So if I want to have the constant terms for this mechanism, A is constant, B is constant, and the offset is constant, but D is variable. So A, B, and C. This link is not varying the length, D is not varying, and the offset is not changing. Variables are theta 2, theta 3. We don't have theta 4 because the third moving link is slider. It's going to be S or D. The D graph freedom for this mechanism is 1. So one of these should be given, should be noun. So constant or noun, I can measure the length. They don't change. And theta 2, I assume that it's the variable which is noun. So I'm solving for the remaining, which are theta 3 and S. So how can I set up the displacement analysis? I pick a point which is representing O2. It can be any point O2. I don't know the position of a slider, so I cannot locate the location of a slider, but I know the angle of theta 2. Theta 2 is given. Suppose theta 2 is this angle, so I can draw this line. And this line just go in the direction of theta 2 by the length of A. You end up to point A. So I could end up to point A. Now, if I find the location of the slider, I'm done. How can I find that? I know that the slider has the distance or offset of C from the ground. So from the ground, draw a line with the distance of C. I know that the slider is going to be any point on this line because it should have the distance of C from the ground. But where it's going to be, I'm going to use this information. Link B has the distance of B from point A. So I draw a circle. I draw a circle with this center with this center and the radius of the B. So it's gonna have intersection with this line right here, and it can have another intersection on the other side. So if I connect this to this one, I'm gonna have my offset slider again. O to A, O to A, A, B, slider should be located here. Then you can measure this distance, S or D, by measurement. And angle of theta 3 by measurement again, we can find it. Do the same thing for the other intersection. S2, this is S1 for first node, S2. And the angle of theta 3 is measured by this. Theta 3.
That'll be the cross. That's not the cross version, right?
It is. But there is one point there. There is possibility. Here I had two intersections, but suppose I have this point A is here and line is there. There is possibility that when you draw the circle, you don't find any intersection. So this is another possibility. Or you might find only one intersection. When this circle is tangent to the line, you might find only one solution. Two modes, one mode, or no possible mode. Same as the 4-bar mechanism. There are three possibilities that you might see in this problem. Any question on this? All right. I'm not gonna go through the example. It's similar to what I did, except here we have the numbers, but the step would be the same. I'm gonna start analytical approach. So in analytical approach, we are gonna use the system of equation to solve for the unknowns, and we will see how can we do that. So suppose we have a 4-bar mechanism. Like this. If you remember everything on analytical approach, it's starting from vector loop equation. In analytical approach, we treat each link as a vector. So here, in this 4-bar mechanism, we have 4 links, 1 ground, 2, 3, 4, we treat each link as a vector. So this link should be considered as one vector, this link as another vector, vector 3, vector number 4. So we treat them as a vector. Each vector has a starting point and ending point. It's very important. So I will start with link 2. I treat this as a vector. It has point A, OA here, and point A up there. I can pick point OA as a starting point. Also, I can pick point A as a starting point. So if I pick OA as a starting point, point A is going to be ending point for the vector. So let me pick this. So I put the arrow at point A, meaning that a starting point is point OA, ending point is point A. So you can do the vice versa. Pick this point as a starting point, put the arrow in this direction. But it's better that we do in this way for this thing, because this point is the origin. If this is y-axis, this is x-axis, it's better that we go in this way. So we call a vector 1 with the length of A. So I pick this link as a vector, label the angle for link 2 at a starting point. So this link has an angle with the ground. I can either measure at point A or point OA. But if you pick ending point at point A and a starting point at OA, measure the angle at the starting point always. So if this is the case, theta 2 will be this one. Link 3, I can either pick point A as a starting point or point B as a starting point. If I pick point A as a starting point, point B is gonna be the ending point, arrow goes this way. If you do the vice versa, you go in this way. It doesn't matter which way you go. I pick this one for now, but you can do the vice. Since for link 3, it has a length of B. For link 3, since I started the vector at this point, I should measure the angle with the ground at point A. Theta 3. 3 meaning that the angle with for link 3. For link 4, it has OB and B. Either point can be a starting point. I pick point OB as a starting point and point B as the ending point. This is my selection. Your selection can be different. You can pick this point as the ending point, put the arrow right here. If I do this, then I should measure the angle of theta 4 at this point, not this point. Starting from ground, go all the way to the counterclockwise direction. And OAOB is going to be the last, the ground. I put the arrow, I assume that the starting point here, ending point would be at OB. Now I created 4 vectors because I had 4 links. Now look at the points. We have 1, 2, 3, 4. We have 4 joints. Look at the joint in which 2 arrows ending to that. Point A is not that point because only 1 arrow is ending to that. But point B is the only point with 2 arrows ending to that. So try from the origin. Try to reach point B through 2 different paths. So if I start from here, I can say vector OAA, vector OAA, vector, plus vector AB, vector OAA plus vector AB, you are gonna end up to point B. Just stop there. Find another path to reach point B. Vector OA, OB, vector OA, OB, it's a vector, I put a vector sign on the top of that. Plus this vector OBB, you are gonna reach to point B. So meaning that this side equals to this side. We call this equation vector loop equation. When you write this equation, you are done with the 50% of the problem. The rest is the mathematical equation. But that part is important to driving the vector loop equation.
But if you go the opposite side of the arrow, you have to put a negative.
Which one, for example?
Like let's say AB was pointing the other way. You
AB.
would put a negative, right?
This one.
Yeah.
So then point A is the point that you should write the vector. It's a good example. Okay, he's gonna pick point A as the ending point, not point B. So theta 3 should be defined here, first of all. Okay? There is no change on theta 2 and theta 4. The only point which has two arrows on that ending to that is point A.
Oh.
So try to reach point A. It's gotta be OAA. Stop there. Stop there. Going through this way. OA, OB plus OBB plus BA. These two equal to each other. This is true. This is correct. Depending on how you label the links, you might get a different vector loop equation. But be consistent. If you label this, you cannot use this vector loop equation. Good. Any questions so far? I will start driving the equation for offset slider crank, for no offset of the slider crank tomorrow. I just wanted to show you how we can set up the vector loop equation, then we go to driving the equations.